Our diagram here represents a voltmeter connected with a capacitor and a source. Now the voltmeter is essentially just this part of the circuit. It consists of a large resistance connected with a coil and a magnetic field. The large resistance and the coil are connected in series. Then this combination is connected in parallel with whatever circuit you're trying to measure across the 2 points between which you want to measure the voltage. Excuse me. Now, if we want to measure the voltage across this capacitor, then we would hook the leads from the voltmeter here and here on either side of the capacitor, one on each side. Now what happens is you've got a large current flowing through here. Okay? A small current is going to come up and flow through the magnetic field, or through the capacitor. Depending on what the potential difference is between here and here, you're going to have a current between here and here. Okay, so you have a very small current because you have a large resistance. It's not going to tap off very much current out of this circuit unless the circuit also happens to have a very large resistance for some reason. But usually this resistance will be a lot larger than any resistance you're likely to have in a circuit that you're trying to measure. So we have a large current that flows through the circuit and a small current being tapped off to flow through the voltmeter. Now when that small current goes through the magnetic field, knowing what the large resistance is here, we can determine what the voltage must have been across the large resistance from the current that we get through here, and translate that into what the voltage must have been across here, because the voltage across this large resistance is the same as the voltage across this circuit element. So again, the strategy is to tap off just a little tiny bit of current, but this time by hooking the whole voltmeter in parallel, rather than in the case of the ammeter. And let's just take a look at that again, where we have a small resistance that's effectively in series with the circuit, and then the large resistance in parallel with it. There are a lot of similarities, but the strategy is different because we're trying to accomplish something different here. We're trying to determine the current through this large resistance by the deflection of this coil, which will allow us to determine the voltage drop over the resistance in the coil, which will be the same as the voltage here. We don't always use that with a capacitor, but in the situation that we looked at in class today, we did have a capacitor across here. If we had a resistance across here, as long as this resistance is small compared to this one, we get a good determination of the voltage.